To find k in this exponential equation we have here, I'll be applying the laws of indices. Alright, so we have here 11 to the power of 3k minus 1 all over k equals 1. So the first law I'm going to apply here is the law of indices that says any number raised to the power of 0 equals 1. So now, if for instance we have 11 to the power of 0, the law says that this becomes 1. Now we have 11 raised to the power of 3k over k in the left hand side. I'm going to also make this, the left hand side, to be in the base 11 raised to the power of 0. So we will now have here 11 raised to the power of 3k minus 1 all over k equals 11 raised to the power of 0. So since these bases are equal, we can now equate the powers to have 3k minus 1 over k equals 0. Now that we have this, the next thing is for us to eliminate this fraction at the left hand side through cross multiplication. So if we cross multiply, we have 3k minus 1 equals 0 times k. This gives us 3k minus 1 equals 0. Now we are going to add 1 to both sides of the equation. If we add 1 to both sides, we have 3k equals 1. Divide both sides of the equation by the coefficient of k, which is 3. So we divide by 3. We divide by 3. These 3 we cancel out 3. So our k equals 1 over 3. And these are answer. What if you have an equation in this form and you have to find the value of the exponent k? How do we go about it? It's very easy. If you notice, we have 6 raised to the power of k in 3 places, 2 raised to the power of k in 3 places. Okay, so the first thing I'm going to do here is to factor out the common term. And at the numerator, we have 6k common, so we factor it out. We have 6 raised to the power of k. And then if we divide, we have 1 plus 1 plus 1, right? All over here, 2 raised to the power of k is common. So we also have 1 plus 1 plus 1 equals 81. Now we are going to sum up the terms in the bracket. 1 plus 1 plus 1 will give us 3. So it's going to give us 6 raised to the power of k times 3 all over 2 raised to the power of k times 3 equals 81. Now that we have this, if you notice, we have 3 that is common to both sides, and 6 raised to the power of k is multiplying 3, 2 raised to the power of k is multiplying 3. We can eliminate this by cancelling out what is common at both the numerator and the denominator. We will now be left with 6 raised to the power of k all over 2 raised to the power of k equals 81. Now we have this, right? Okay, remember in indices, if you have a over m raised to the power of n, you can simplify it to be a raised to the power of n all over m raised to the power of n, right? So now that this is expressed in this form, we can also re-express it to be in the form of a over m all raised to the power of n. So let's do that here. So this would give us 6 over 2 all raised to the power of k equals 81. So that these two will go into 6 3 times. We now have 3 raised to the power of k equals 81. So we will now have here 3 raised to the power of k equals 81. Let us express 81 in base 2 raised to a power. So we have here 3 raised to the power of k equals 81 is equivalent to 3 raised to the power of 4. That is 3 times 3 times 3 times 3. So we have here 3 raised to the power of 4. The bases are equal, so the powers are equal. So if this cancels out, we have k equals 4 as the answer. If you find this video helpful, please do not forget to leave me a comment, like this video, share, and subscribe to my channel.